All right, so on the video, this is still 15.2a. On the video I had you watch on Friday, I did the second example and the last example on this page. So today I'm going to do the first and the third examples for you. And then I'm also going to do 15.2b, which is just 2 more graphs. Okay? So, let's start with this one right here. This is what I like to call a mother function. If you didn't have me before, that's what I call a parent function. Mother, parent, get it? Helps you remember it a little more. How do I know that it is a mother function? Well, first off, I can see clearly that h is what? 0. And k is also 0 because there's no number out here. And there's no a or b clogging up any of my business there. So with no a or b to worry about, and an h and a k both as 0, you have a mother function. So, I have h equals 0 and I have k equals 0. Which one of those is my asymptote? H is my asymptote. It's exactly opposite of what it was when you did exponentials. So let me draw in my asymptote right there. And what do I do now? I plug in the points. Well, I can't quite plug them in yet.
Oh, you gotta get logged out.
I have to rearrange my equation. In other words, I need to rewrite my equation in exponential form. So this is my y, correct? F of x is the same thing as y. So I'm going to take the y off there, and I'm going to put the y on this side to make life a little bit easier, because we like it when the log is on the left. For some reason, it's just easier to go to exponential form. So what is my base? What is my exponent? Equals what? Is x by itself? Yes. So I can go ahead and start plugging stuff in. So I'm going to start off plugging in the -2. By the way, the k value is what determined the middle of this side. Shh. The k value is what determined the middle of this side right here. And then they filled in the rest for us, so that's helpful. So let's see. 2 to the, I'm going to start off with -2. Now, I'm going to put it in parentheses just because it's always better to err on the side of putting parentheses than not, if you're wondering if your calculator is going to have an issue with anything in an exponent. And I get 0.25. By the way, kudos to you if you can do that one in your head. That means you're really starting to understand this whole exponent thing. What is 2 to the -1st power? 1/2, which is 0.5. What about 2 to the 0?
1.
2 to the 1st? And 2 to the 2nd?
4.
So let's go plot our points. 0.25, -2. 0.5, -1. 1, 0. 2, 1. And 4, 2. And my graph looks something like that. What is my asymptote? Anybody?
X0.
0.
My asymptote is not 0. X equals 0. And yes, I am particular. If you just write the number 0, you are not giving me the equation of a line. Okay? What is my domain? X is greater than 0. Bless you. And what's my range?
All real numbers.
All real numbers. Okay? So? By the way, your test is going to be graphing heavy. It means the most of the points of your test are going to be graphing points. As it is right now, I think you have 4 graphs on your test.
Oh, how many problems?
Like 10.
On a test?
Uh-huh. So you have like 4 graphs, and then you have like 6 questions like these guys. Your favorites. Okay? That's what your test is going to be. Okay, so this example I did in the video on Friday, so you can check that one there. Now let's go down to this guy. What is my h value? -1. What is my k value? 0. Now, let's talk about our transformation before I go any further. If I have an h value of -1, what does that mean as far as the transformation? I have a shift. Please don't say a shift of -1. Please don't say a shift left -1. Say a shift left 1. Because it is talking about a distance that you are shifting, and you cannot travel a negative distance. Negative is a direction, not a distance. Does that make sense? If I run a mile that way or I want to run a mile that way, don't tell me I ran a negative mile. I ran a mile. It was just either in a positive direction or a negative direction.
Do you run a negative mile
Okay.
if you're sitting on the couch?
Maybe. I don't know. Okay, so I have a shift left 1. What does the K mean? Do I have any other shifts? No. Are there any other numbers here that would be causing a transformation? -2. Would you say that's an A value or a B value?
It's an A.
That's an A value. And the first thing I notice about that A value is that it's negative. What does a negative A value mean? It means I have a reflection. What kind of a reflection?
Across.
A vertical reflection. Because A determines vertical stuff. If you are the kind of person that talks about an axis, it is a reflection across the x-axis, which some people get that mixed up, but the vertical movement goes from top to bottom, and that's across the x-axis. Now, in addition to it being negative, it is a 2, so what does that mean? What kind of stretch?
Vertical.
Vertical stretch of 2. And we're not really going to worry about B values on these guys. We're just going to do A, H, and K. So that's really all you got to worry about. Okay? All right, which one's my asymptote? -1. How do I write that equation? X equals -1. By the way, I should be able to fill out my domain and range here without having done anything else. What's my domain going to be? X is greater than -1 because everything we're doing, we're graphing only to the right. We don't have any any horizontal reflections because that would be a B value and we're not going to address those. So we're always going to have greater than. And my range is always going to be all real numbers for these guys. So I'm all done there. What do I do next? Let's see. This guy's got to go there. And I'm going to fill in some values around there. Okay? So now what do I do? How do I plug stuff in? I got to get X by itself, right? So I'm going to move the Y to the other side. Now, if you were struggling on last night's homework at all, most of the people in most of my classes that have asked me questions because they struggled, it has to do with the fact that you kind of get fluent with this whole rewriting thing and you think you can do it in your head. But if you make even one tiny mistake, it throws everything off. So I just recommend that you write out your steps. It just makes it less likely that you'll make a mistake. So what do I need to do to get my log by itself? Divide by -2, or how else could I do that? Multiply by -1/2, because that's the reciprocal. So I have log base 2 of x plus 1 equals y over -2. Now I'm ready to go to exponential form. What's my base? To the what power?
2 to the y.
Y over -2 equals x plus 1. Again, do you notice how I'm taking the time to move the y over to this side? Divide both sides by something. Now I'm going to subtract something from both sides. It just gives you a little bit more confidence that you know what you're talking about when you get to your equation. So I have 2 to the y over negative 2 minus 1 equals x. And now I got to plug things into my calculator. So 2 to the, whenever your exponent has more going on with it than just a plain old number, make sure you're putting it in parentheses. So let's see, negative 2 divided by negative 2. Here I say do it in parentheses, and I forgot to put the parentheses. There's my parentheses. That way my calculator will know that the very next number is a k value instead of an h value. And I get 1 as my result there. Now I'm going to arrow back, and I'm going to change that first negative 2 to a negative 1. And I get 0.4. Now I'm going to change the negative 1 to a 0. And I get 0. Change it to a 1. And I get negative 0.29. I'm going to call that negative 0.3. And finally a 2, and I get negative 0.5. So as soon as I plot my points, I'm done. 1, negative 2, 0.4, negative 1, 0, 0, negative 0.31, and negative 0.52. So this one is a more gradual curve, but it will continue going out there. And that's what we've got. Any questions about that one? And the one at the bottom of the page was also on the previous video. So now I've covered all the questions from 15.2a. Okay. All right, you ready for 15.2b? It's just 2 more graphs. It's nothing new. It's just 2 more graphs. So turn the page. Graphing logarithms continued. The only difference on these 2 graphs is, if you look at the equation, there's no, what? There's no base listed, right? So it's just 2 more graphs that are exactly the same process as the front side. We're just going to see how to do it with tens and the e's, okay? All right, so step 1, identify what is h. Negative 7. What is k? Negative 2. Which one of those is my asymptote? Negative 7. Okay, so are there any other numbers in my equation other than h and k? No. So as far as listing my transformation, I have a shift left 7 and a shift down 2, and that's all that's going on. Anyone know what the parent function is? Cross off all your numbers, and that's your parent function. Y equals log x. That would be the parent function there. Okay. All right. So let me put my k value in the middle. Fill in some values around. And I'm going to take my time getting my log by itself. Again, I'm going to go ahead and write equals y on the right, just because it makes life easier. And I'm going to start off by moving that 2. So I have log of x plus 7 equals y plus 2. Now that my log is by itself, I'm going to go to exponential form. What is my base? 10. Do you remember the name of this kind of log? It is a common log because there's no base written, so it's base 10. So 10 to the what power? Y plus 2 equals, okay, and now what am I going to do?
Subtract 7.
Subtract 7. So 10 to the y plus 2 minus 7 equals x, and that's what I'm plugging stuff into. So has anything changed on this from the previous problems? Only difference being I want to make sure you know that there's a 10 there if there's no number listed as your base. So, 10 to the, again, put that exponent in parentheses in your calculator. -4 plus 2. Close my parentheses and minus 7. And I have -6.99. I should have kind of stayed out of there. Running out of room there. All right, now I'm going to change my -4 to a -3. I have -6.9. Changing the -3 to a -2. I have -6. -1. I have 3. And finally to 0, I have 93. Wow, that got big fast. Why did it get big fast? Because your base is 10. Think about powers of 10. 10 to the 0 is 1. 10 to the first is 10. 10 to the second, you're already up to 100. So it doesn't take a very big exponent on a 10 to make the number really big, right? 10 to the third, you're at 1,000. So clearly I'm not going to be able to graph 93. But I can graph the rest of them. -6.994. -6.9 is almost the same number, but very close to the previous one. But I'm on the wrong side, aren't I?
Yeah.
How about -4 and -3? We'll pretend that those points aren't there. -6, -2. Now be careful on this one. My brain wants to go -3, -1, but it's not. It's +3, -1. And then 93, 0 doesn't fit on my graph, so I'm just going to aim in that direction. Does that make sense? What's my asymptote? X equals -7. What's my domain? X is what?
Greater than 1.
Greater than what?
-7, my bad, I'm on the other column.
-7. And what's my range?
All the numbers.
All real numbers. So? All right. Last one. All right, last one. What is my H value? 1. What is my K value? 4. Do I have any other numbers other than H and K? So if H is 1, I have a shift right 1. If K is 4, I have a shift up 4. Which one is my asymptote?
H1.
Okay. And then my K value I put in the middle here, and I fill in with values around it. I am going to, let's see, I'm going to put my equals y on the other side so that I can start moving things around. I need to start off by subtracting that 4. So the natural log of x minus 1 is equal to y minus 4. Now when I go to exponent form, what is that base? E. What's the exponent?
Y minus 4.
Equals.
X minus 1.
So the key there, you got to remember natural log means it's got a base of e. Last step, I'm going to add 1. So I have e to the y minus 4 plus 1 equals x, and that's what I'm plugging numbers into. So e to the, again, throw this in parentheses, 2 minus 4. By the way, as I close my parentheses and push plus 1, e is an ugly number, if you remember from last semester, which means that every single thing you calculate with is going to be an ugly decimal. So just be prepared for that. 1.13, we're just going to call it 1.1. Now I'm going to change that 2 to a 3. And I have 1.36, I'm going to call that 1.4. Change the 3 to a 4. I have a 2. Change the 4 to a 5. I have 3.7. Change the 5 to a 6. And I have we'll call it 8.4. So, 1.1, 2, 1.4, 3, 2, 4. So those ones are all really close to each other. And then 3.75. 8.4 is barely off my graph, so I think I can fit it right about there. And I just got to fill in my last bits of information. What's the equation of my asymptote? X equals 1. What's my domain? X is greater than 1. What's my range? All real numbers. So, quick reminder about what I said. Your test has 4 graphs on it. I believe that those graphs are worth 8 points each, and it's a 50-point test. So what's 8 times 4?
32.
So 32 out of the 50 points, which is more than half, is on graphing. Okay? So be prepared for that. The other points are off those problems like these guys, okay? Happy studying.